Hi guys, I'm Abhishek, and in this video we are going to mainly learn about Kruskal's algorithm and what its uses are. But before we learn what exactly Kruskal's algorithm is, let us see what types of graphs there are, what's a weighted graph, what's a spanning tree, and what's a minimum spanning tree. So there are two types of graphs, namely the undirected graphs and the connected graphs. So an undirected graph is a graph in which the edges do not point in any direction. That is, the edges are bidirectional. Here A, B, C and D are the vertices, and AB, BC, CD, DA are the edges. Here AC is also an edge since these two vertices are connected. And a connected graph is a graph in which there is always a path from a vertex to any other vertex. So now coming to what weighted graphs are. So weighted graph is a simple graph with weighted edges. The weighted edges are used to compute the shortest path. So a weighted graph consists of set of vertices which is generally represented by alphabets, but in this diagram which I took as an example, it's represented by the numbers 1, 2, 3 and 4, which are circled and marked in yellow. And then we have a set of edges. So here the line which connects two vertices is called an edge. So here this is an so the lines are the edges. So this is an edge, this is an edge, this is an edge, this is an edge, and this is an edge. So weight of the edge, which is generally represented by the numbers. So in this diagram, this is an edge which is represented by the number 3. This is an edge which is represented by the number 1, and so on. Now coming to what is a spanning tree. A spanning tree is a subgraph of an undirected connected graph which includes all the vertices of the graph with the minimum possible number of edges. If a vertex is missed, then it's not a spanning tree. And these two are the examples of a spanning tree. So what is a minimum spanning tree? A minimum spanning tree, which is generally abbreviated to the word MST, or minimum weight spanning tree, is a subset of the edges of a connected edge weighted undirected graph that connects all the vertices together without any cycles and with the minimum possible total edge weight. So let's see an example of MST. So this is a spanning tree, and A, B, C and D are the vertices. A, B, B, C, C, D and D, A are the edges, and the numbers 1, 2, 5 and 4 are the weights of the edges. So we saw that we saw that a minimum spanning tree is a subset of the edges of a connected edge weight undirected graph. So a minimum spanning tree is a subset of the main spanning tree. So let's see what the subsets are. So according to this spanning tree, the subsets can be written as this. But in this, there are 3 edges here, and when we add the numbers, like when we add the weight of the edges, we get the sum as 11. And in this subset we get the sum as 10, and in this subset we get the sum as 8. But what is a minimum spanning tree? A minimum spanning tree is the spanning tree with the minimum possible total edge weight. So here, since here there is the sum of the edges, the sum of weights of the edges is just 7, we can see that this is known as the spanning tree. Since comparatively 7, 8, 10 and 11, 7 is the least. So we know that this subset of the spanning tree is called the minimum spanning tree. Now coming to where MST is used and its applications. So MST, which is called the main minimum spanning tree, is used to find paths in the map to design networks like telecommunication networks, water supply networks and electrical grids. So the minimum spanning tree from a graph is found using the following algorithms. It can be found by using the Prim's algorithm and Kruskal's algorithm. But in this video, we're only going to learn how um, how we can find the minimum spanning tree using Kruskal's algorithm. So let's see what Kruskal's algorithm is. So Kruskal's algorithm is a minimum spanning tree algorithm that takes a graph as input and finds a subset of the edges of that graph which form a tree that includes every vertex and has the minimum sum of weights among all the trees that can be formed from the graph. And how the Kruskal's algorithm works. So it falls under a class of algorithms called greedy algorithms. So that find the local optimum in the hopes of finding a global optimum. So there are so we all know that there are 6 types of algorithms, and greedy algorithm is one of them. So in this algorithm we start from the edges with the lowest weight and keep adding edges until we reach our goal. The steps for implementing Kruskal's algorithm are as follows. Sort all the edges from low weight to high. Take the edge with the lowest weight and add it to the spanning tree. If adding the edge creates a cycle, then reject the edge. Keep adding the edges until we reach all the vertices. Listening to these steps, it might be a little vague, but let's see an example. So finding minimum spanning tree using Kruskal's algorithm. So let's take this as an example. So here this is a spanning tree, and we know that A, B, C, D, and D are the vertices, and singularly this is called as a vertex. And here the numbers 5, 2, 1, 3, and 2 are the weight of the edges, and AB, BD, DC, and CA are the edges. So here this is called a loop. So any edge that starts and ends at the same vertex is called a loop. So our first step is to remove all the loops. So this is in loop and this is in loop. So in this step we remove the loops, and then we get this spanning tree with no loops, just some vertices and edges and the weighted edges. So now our second step is to remove all parallel edges between two vertices except one with the least weight. So here our parallel edges is the one that is parallel to AC. So but since we have to keep the one that is the least with the least weight, we'll be keeping 2 and we'll be removing 12. So in this graph, vertex A and C are connected by two parallel edges having weight 2 and 12 respectively. So we'll remove 12 and keep 2, since 2 is, as I told, 2 is the has the least weight. So now we get the spanning tree. Now let's see what the step 3 is. The step 3 is to create the edge table. An edge table will have names of all the edges along with their weight in ascending order. And there are 5 edges in this above graph, which is AB, BD, DC, CA, and BC. Here BC is also an edge, keep that in mind. And so there are 5 edges in the above graph, and so our edge table will also have 5 columns. So this is an edge table. So since the vertex BC has the least weight, BC comes first in the edge table. Here we did say that their weights are kept in ascending order. So here BC has the least weight, so BC comes first in the edge table. Both the vertices AB, so both the vertices AB and AC have a weight which is 2, and so you can keep any vertex first. We have to write both of them, but you can keep them in any order. Here I wrote the edge AB first and then the edge AC. Now the vertex DC has the next minimum weight, which is 3. So this edge has the next minimum weight, which is 3. and then the vertex BD has the highest weight among all the vertices, and so BD is written in the end. Here BD has the highest weight, so it's written in the end. And so this is how we make our edge table. So how to find an MST? So to find the MST, which is the minimum spanning tree, we will start from the smallest weight edge and keep selecting edges that does not form any circuit with the previously selected edges. So our graph has 4 vertices. So once you have 4 vertices, your MST can only have 3 edges. Since our MST is a subset of our main graph, so we cannot have the same edge as the main graph or more than it. So we'll have only 3, since in this we have only 4 vertices. So here now we'll make our minimum spanning tree. So the edge BC with the weight 1 is the smallest, and so we first select our edge BC, and then 2 is the next smallest weight in the edge table, and edge AB does not form a circuit with edge BC, and then so we select edge AB. But if in your edge table you have written the edge AC first, then you could select AC first and then AB. Now when you say in this, the third edge is AC, and 2 is the next smallest weight. But if we select our edge AC here, it will form a circuit, but a minimum spanning tree cannot form circuits, so we'll have to ignore this edge and forget about it. And so our next smallest weight is the edge DC, and it does not form a circuit with the previous edges, and so we select edge DC. So DC has the next smallest weight, so we select the edge DC. And and we saw that our MST can only have 3 edges, so we have finished selecting 3 edges. So since we got 3 edges, we will ignore the edge BD from the edge table. So even though there is BD left, we have to ignore it because we can have only 3 edges, and we have already selected those. Thank you. I hope you have enjoyed this video, and I hope you comment and like and subscribe. And even if you have any doubts, you can go down and ask them. I'll be trying my best to clarify them. Thank you.